Hey guys, welcome to the video today, and today I'm going to be doing some problems from my pre-calculus final exam review, and these are the free response questions. So if you are one of my subscribers and you're not part of my class, hopefully these are some problems that you might see on a pre-calculus test, or there's just some extra practice. But I'd like to go over those with you, over them with you guys now. So let's take a look at the first one, and if you look at your right here, I have Mr. Can't Swim. All right, so I'll let you go and read that for a second, then I'll start going through it. So now what we want to do is we want to draw a picture. I think one of the most important things when we do these is to draw a picture. And let's take out of this what are the vectors that we'll be using. So here we have he's traveling northwest at a speed of 45 miles per hour, so that's one vector. Then we have another vector. The current is flowing directly north at 5 miles per hour. And we have another vector. It's a gust of wind that sails at a speed of 20 miles per hour at a direction of 20 degrees south of west. Now, these are a little bit different than what we've been doing in class normally, in that we did a lot of things with bearing. And I think that on the final exam, we do actually use bearing. So bearing, remember, starts 0 degrees here and goes around the circle that way. For these problems in particular, we're going to actually look at a compass. So we've got north, south, east, and west. And what we're going to do is we're going to take a look at these here, and we're just going to use these as our three vectors. So what I'm going to do here, I'm going to put vector 1. Okay, vector 1 is going to be northwest, which is going to be here. And that's 45 degrees, because we know that if it goes northwest, then it's automatically 45 degrees, and it's 45 miles per hour. Okay, mph. So our components for this, our x and y components, going to be the same thing. It's always going to be, x is going to be the magnitude of the vector times the cosine of theta, and y is going to be the magnitude, the magnitude of the vector, v, times the sine of theta. So let's go ahead and put those in there. We're going to go first here, and we're going to get 45 degrees, and 45 is this is always the miles per hour is always going to be our magnitude. So we're going to go 45 miles per hour times the cosine of 45 degrees. And this x is negative because it's in the second quadrant, so we're going to put a negative in front. And we're going to have 45 times the sine of 45 degrees. Okay. We're going to calculate that out in just a second. We've got our second vector, which is directly north. So directly north is going to be right here. All right, so that we can use 90 degrees, right? Because this is 90 degrees. If we start here at 0, then we would go all the way this way, and that would be 90 degrees. So we're going to have, or you know, I even think better here is we don't have an x coordinate here. The coordinate at this point is going to be 0, 5. So we can just go ahead and put 0, 5. So if it's on one of the axes, we can just go ahead and, one of the x or y coordinates is going to be 0. So our third one is going to be the wind, and that's 20 miles, 20 degrees south of west. Now south of west, we're going to start at west, and then we're going to go south. So we're going to go south 20 degrees, it's going to look like that. Okay, and it's 20 miles per hour. So we're going to have, they're both negative because we're in the third quadrant. So I'm going to say negative 20 cosine of 20 degrees and negative 20 sine of 20 degrees. All right, so let's go ahead and throw that in our calculator, and we will come back and I'll have that for you just a second. All right, so I plugged this in my calculator and I found them here. So now we're going to go back here and I put them in my solution. Okay, so let's hold on one second. I want to make sure I have these on the side. All right, so let's go back to here and let's notice that what we're going to do here now is we're going to take all three vectors and add them together. So you're just simply going to add the x's and add the y's. That's it. So we're gonna add the x's. So let me change this color. This is the x. We're going to add this one, and this one together, and then we're going to add this one, and this one together, and we're going to add those together, and we'll see what we get. Okay, so that'll be my resultant vector. All right, so we add these two together, and we're going to get negative 50.6. We're going to add these together, and we're going to get 25. All right, so now that's our resultant. Now what we're going to do with our resultant, we're going to find the magnitude of that, and to find the magnitude of that, we're going to, now this is going to be our new speed. It's the square root of x squared plus y squared. Okay. All right, so we're going to do that in our calculator again. All right, so let's go and do that on our calculator. When we do that, we're going to get 56.4 miles per hour. Okay, so this is your new speed. And now we want to find the direction. Now notice here that the x here is negative and the y is positive. So if the x is negative, the y is positive, this r is going to be somewhere over here, right? So with it being over there, we are going to find this angle right here by using the inverse tangent of y over x, and we're going to keep the bottom here positive. Okay, and it has to do with that inverse tangent. It's going to give us a bad number if we want negative. We're going to keep them both positive because that's going to give us the angle right there. Okay, so we're going to plug that again in our calculator and see what we get. That's going to give us 26.3 degrees. Now what that tells us is that this angle here is 26.3 degrees. But we want to make sure that we say that in the correct way, because we want to make sure that if we're giving these directions to somebody, they know exactly where to go. If I just gave them 26.3 degrees, they might think that we're over in the first quadrant because we're starting here at 0. So I have a bunch of ways I can do this. I can say that this is 26.3 degrees north of west, okay, because it starts here at west and it goes north. Okay, I can also say this is, if I added 270 degrees to that, because this is 270 all the way around right here, that would give me 296.3 degrees bearing. Okay, because remember, bearing starts here at 0 degrees. Or the other way is to subtract 180, and that would give me the regular angles that we normally deal with. So either way is fine. I suggest that whatever the angles that are given to you in the directions, that's what you want to stick with. So since they're given to us in compass direction, we're going to go ahead and stick with that answer there. But if I gave it to you in bearing, or another teacher gave it to you bearing, you're going to want to use bearing, which is right here. Okay, so let's take a look at the next problem that was on my, and I'm going to finish this video off with just this problem because there really isn't enough time to go over the whole thing. So this first part will be the calculator part. Now, for my class, I moved the piecewise function to the no calculator part, so I'll quickly go over how to do this without a calculator. Okay, so we're going to graph this without a calculator. Now, this is a logistic function, and what I would do is plug in 0 in for x, and we'll plug in 0 in for x, either 0 is 1, okay, and we're going to get negative 2 over 4. Okay, so I plugged in 0, and I got negative 2 over 4, which is going to give me negative 1/2. So negative 1/2 is right here. And I know that this is a logistic function that looks something like this. Okay. Because I know that this -2 is my limit to growth, but except it's on the bottom, and I know the logistic function won't cross this asymptote here of y equals 0 because yeah, y equals 0 because this doesn't have like a plus or minus at the end of it. So, but I want this as a piecewise function less than 0, so I'm only going to have the darkened part here that I have here. Next, I'm going to have the sine of x. Well, we know what the sine of x looks like. Pretty much everybody should know what the sine of x looks like. Just one of our basic functions. Looks like this. Okay, that's 1 and a positive 1, a negative 1. This is 2 pi. I'm going from 0 to 2 pi, so that's 0 to 2 pi, except I need to have an open circle at each of those points because this is not equal to. All right. Now the next part is 2 pi over x. Now that is that's a reciprocal function with a rational function with the asymptote right there. So normally it would look something like, you know, I'll just draw a dotted line. It looks something like this, right? That's normally how we would see a rational function like 1 over x. But this is 2 pi over x. It's just a constant. What we're going to do is we're going to plug 2 pi in here for x, and we're going to get 2 pi over 2 pi, which is equal to 1. That's my y value. So at 2 pi, I'm going to be at 1 right there. Close that circle. Follow my line. I'm going to go ahead and go back to black here. Okay, follow my line. So go this way. Okay, and that's it. Now I wouldn't want us to have this stuff in here. Okay, so I wouldn't want to have that part because that's really not part of the. Okay, it's really not part of the graph. All right, so there we go. There's our graph. Okay, so now let's go ahead and take a look at the limits that I had. Now I'll shrink this down a little bit, see if we can be able to see that. So let's look at these limits here. This is for the calculus students in my class are looking at pre-calc. The limit as x approaches negative infinity. So as I go to negative infinity here, I'm going to approach this y horizontal asymptote, which is -2. The limit as x approaches positive infinity goes towards this horizontal asymptote, which was 0. The limit as x approaches 0 from the left, as I approach 0 from the left, I'm going to get to -1/2. As I approach 0 from the right, I'm coming this side, I'm going to get to 0. As I approach 2 pi from the left, I'm going to go to 0. And as I approach 2 pi from the right, it goes to 1. All right, so those are all the calculator portion. Part 2 will be no calculator. All right, see you soon.